Welcome to Spring LIB.
So here in this question we are given that there are two roads A, B, D and this DE, and they are connected with three collars, collar A, collar B and collar E, and we are given that the angular velocity of the road ABD is given as 5 radian per second and the direction is clockwise. So the direction of this road ABD is in clockwise direction, and we have to determine two things. In the A part we have to calculate the angular velocity of the road DE. So the angular velocity of this road we have to calculate omega ED, and in the B part we have to calculate the velocity of the collar E. This point, the velocity of collar E, that is VE, we have to calculate. So proceeding with the solution, we'll be locating the eye center for the given instant, and for that we'll be making perpendicular line to the velocity vector VB, VA. So this is the perpendicular line to the velocity vector VB, and this is VA. Perpendicular to this is this vector, so this is the eye center. Now we are taking the angle made by this line, the line ID with the horizontal be phi. So let us calculate the value of phi first. So tangent phi will be equals to, this dimension is 200 mm divided by this total dimension is 400 mm. So 200 over 400. So from here we'll get the value of phi as 26.565 degrees. Now next I will be calculating this length ID. So the length ID will be equals to, we're going to use the trigonometric here, so 400 over cosine phi. So 400 over cosine phi we have 26.565. So from here we'll get the value of ID as 447.21 and the unit is in mm. Now we can easily calculate the velocity Vd. This velocity Vd will be equals to omega ABD times the length this ID. So we're going to plug the values here. This is 5 times this one is 447.21 mm. So the velocity comes out to be as 2236.1 mm per second. So this is the value of velocity of Vd. Now next we're going to locate the eye center of the road ED. So this is the velocity vector at point D, and this is the velocity vector at point A. This is V. So perpendicular to this line will be this, and perpendicular to this would be this. So this is point J, the eye center. Now next I will be calculating the value IJD. This distance JD will be calculating. So the distance, let me denote it with L, JD will be equals to 400 over cosine phi. So phi we have already calculated as 26.565 degree. So 400 over cosine, this one is 26.565 degree. So we're going to solve this and we'll get the value as 447.21 mm. Now omega DE we can easily calculate by using VD over LJD. So VD we have calculated as 223.6.1 over this value is 447.21, and we get the answer in radian per second. So from here omega comes out to be as 5 radian per second, and the direction would be in anti-clockwise direction. So this is the answer for the A part. So let me write here, this value is 5 radian per second and the direction is anti-clockwise direction. Now in the B part we have to calculate this velocity VE. Now to calculate this velocity we'll be first calculating this distance LEJ. So LEJ will be equals to this 200 plus this is LJD times cosine phi. So LJD we have calculated as 447.21 cosine 5 we have 26.565 degree. We have used simple trigonometric here to calculate this LEJ, and we will get the value as 600 millimeter. Now the velocity VE will be equals to LEJ times omega DE. So this distance is 600 millimeter times omega DE. We have this value is we have 5. So we're going to solve this and we'll get the value as 3000 mm per second. So this is the velocity VE, and the direction would be in the downward direction. So this is the answer for the B part. I hope you have understood the problem. Thank you.